probably remember the scene where one of the astronauts of Apollo 13, before they go back to Earth, takes a post-it note off the button that ejects the lower part of the capsule. That's UX design at NASA, or that was UX design at NASA. Sam Hashemi, he's UX designer and researcher, and he's going to show us a couple of metamorphoses at NASA, befores and after. Please bring a warm welcome to Sam Hashemi.
Hi guys, my name is Sam. I used to be a designer at NASA, and I want to share a few of the things I learned while I was designing there. I should say first, I'm no longer at NASA. I now work at a nonprofit called Code for America. We're working on making cities and city government better using technology. And we're working on things like improving transit, redesigning how transit systems are created, among other things. So if that interests you at all, come afterwards and talk to me about it. But I want to talk to you about my time at NASA. While I was there, my team looked like this. We made the software for most of the major missions. And me and 3 other folks in this photo were the designers, and probably the only designers across all the agency. So we had some big shoes to fill. The main thing I worked on was redesigning the systems the astronauts themselves use. So this is aboard the space station, and on the left is this ThinkPad that's mounted against the wall. There's a few of these throughout the station, and the interface on them looks like this. It's not great. Runs on IE6. So there's room for improvement. We redesigned it to look like this. It's nicer, but more importantly, it's on an iPad, so the astronauts can take them with them as they flow through the station and look at it as they actually do the science experiments. This was a big win for them. And I don't want to talk about this project. This was interesting, but as we did this, one of the things we started to ask is, why doesn't software at NASA look like this? The domain is fantastically interesting, but that is not reflected in the interfaces. And we tried to understand why, and there's a few projects that we did to try to move that forward. So I want to share 3 of them with you today. The first one is the moon. This is an orbiter called LADEE, and what it's designed to do, what it actually did, was orbit the moon and try to measure the atmosphere. Because when the astronauts went there many years ago, they found something strange. They found that the atmosphere would glow, and they didn't know why. This was the first time anyone's tried to figure the answer to that question. And so it's an orbiter with a dozen instruments on it, fairly complex piece of equipment. Flew to the moon about 6 to 9 months ago. The main interface that we built for them a while back looked like this. It's fairly simple, but when you look at it, you notice this doesn't tell you that it has anything to do with space. There's some waves on the screen, there's some dots, but nothing really here says that you're controlling power versus controlling something that's flying through space. And so after we built this, we asked, what's the step after this? If we didn't restrict ourselves to just building something that served the function, but actually had a form that we were proud of, what would it look like? And we took a lot of inspiration from a lot of these early sketches of the moon. The thing that stood out was that they'd always show the moon, and they'd always show data on top of that. And we wanted to see if we could bring that information from the orbiter into something like this. So very quickly, I'd like to show you what that looks like. So let me refresh here. So we designed something very simple that they could stick up and see at all times what was happening with the orbiter live. On the left-hand side is the topography of the moon, and that red dot is the orbiter that's going around. Each of these colors represents an activity that gets matched on the right-hand side. So you can see right now it's doing something called a limb UVS orbit. That's when a specific piece of equipment is active and it's doing something. And what's obvious that wasn't obvious before is that A, it's flying through space, B, it's doing something specific right now, and C, it's going to be doing a few set of additional things in the next hour. We made this and we said, this is really cool. Are there other ways we can represent it? So we did this. And I love when things transform like that. I think that's the theme of today, and it was cool that we were able to pull that in. This is the same representation, but now we're actually showing the information of the activities on the moon itself. We made this and we gave it to them, and they basically kept it up like this at all times. And anytime there was a question about what's going on right now, they'd look at this instead of looking at that other display. So it was nice to see that shift, and I think even though it wasn't our intention, when we sought to improve the form of the product, we also improved its function. So that was cool to see. So the next story I have for you is called Deep Space. So let's say you've just launched your new deep space craft. It's going to Jupiter or Saturn. You want it to communicate back with Earth. What do? You stick a big satellite dish on it, and you point it at Earth, and you fire. And then on Earth, you get another big satellite dish, and you aim it up, and you start getting communication. Sounds simple, but unfortunately, Earth rotates, and very quickly you lose track of it. So the solution here, of course, is to have a whole bunch of satellite dishes across the Earth. And what we've done is we've selected 3 sites on Earth that have 40, 50 satellite dishes each, and this is called the Deep Space Network. Anytime there's something far away from Earth, this is what's used to communicate with it. If you look, this red portion, located in Canberra, Goldstone, and Madrid, those are the sites that anytime anything's on Mars or Jupiter or anywhere in space, that's where the information's coming in. So we sat down with those folks and we tried to understand what was going on. They had actually reached out to us because they said, we're dealing with too many spacecrafts these days. There's too many things in space. We're getting overwhelmed. How can we make it possible that our small team can deal with all of this? The interface they had before looked like this. It's not beautiful, but it actually was doing a pretty good job for when you're doing a single spacecraft. It was just breaking down when you get beyond that. Before they came to us, they had actually talked to someone else inside NASA, and they had redesigned it to look like this. It has a green border around it now, so I guess they accomplished that. But beyond that, it was actually much harder to use. And we tried to understand why. Why did it even get here? How did they arrive at this conclusion? When we talked to the other folks that created this, we learned this very unique thing about NASA, which is everything they design is based around checklists. This is the, nearly 300-page checklist they followed to create this. And it met every single checklist criteria, so they had assumed they had succeeded. And so it was painful because you'd see discussions like this. The users of this system would say, hey, this doesn't work for me. And they would say, it doesn't matter. The checklist said we have to do it this way, so they did it. We had a very different approach. We just sat down and watched what they were doing, tried to understand what their day-to-day life was like, and where we could make that better. And I think we learned 2 things. The first is that they had a ton of information, and you needed almost all of it. You need to know every single aspect about this communication to know where it's going wrong or where it's going right. But more importantly, we learned that most of their time was actually spent in the command line. They'd look at these 6 screens of information, narrow down to that one piece, and then type something in the command line to fix it. And what had happened is that this new interface had gotten rid of the command line. So the single thing they relied the most on was lost, and we wanted to bring that back because we thought that was a powerful motivator for them, and we thought we could make it modern, a modern command line interface. So we gave it a shot. I want to quickly show you what that looks like. I'm a big fan of demos, so. So it looks like this. On this left-hand side, you've got a big log of everything that's happened. And on the right, this is all those 6 screens of information redesigned to be in a big scrollable view. There's a ton of it here. And what's interesting is you can jump around very quickly. So if you're interested in the uplink, you can hit that and it scrolls. On this left-hand side, you can tap these sections. That scrolls as well. My favorite feature, I don't know if you noticed, is that the antenna dish, as you scroll, shoots off into space. I was happier about that than the users were, but. And so let's say you're working with these 6 screens of information, and you want to edit something. You could, of course, just click it and edit it. But we really wanted to emphasize the command line. So if you look in the bottom left corner there, I can just start typing, and let's say I want to modify it's called the DEC. So I can type antenna. I've just typed the letter A, and it predicts what it might be and highlights that in the UI. I'm going to hit tab. It predicts the next thing, but I want the deck, so I hit that. I hit tab, and let's make it 144.9. You hit enter, updates in the UI via the command line. And that was great, but we noticed immediately that you don't want to have to scroll through 6 pages of stuff to figure out what you want to edit. So let's look for a field down here. Let's say what looks good to edit? Maybe the con scan. Yeah, let's edit the con scan there. So I can start typing. You notice it's not on the screen, so nothing gets highlighted. But when I hit tab, it notices that it's not on the screen, grabs that section of the UI, and puts it right above the command line so I can see what's happening. Let's edit the sample time, so I can just hit sample time. Do this. We'll make it 50 seconds. Hit enter, updates, fades away, and now I've, through a command line, interacted with the interface that wasn't even on the screen before. What's cool is we showed this to them, and it was sort of that moment where people had known this is like what they had always wanted, but never had. And they just started using it immediately. They were like, this is great, when can we start using it? And to this day, they just love this interface. And as a designer, that's just a very satisfying feeling. Thank you. I've got one more story for you. This is actually one of my favorite NASA missions. It's called Kepler, and it's also a space telescope that looks like this. What it does is something that wasn't done before. It stares at a portion of the sky and just continues to stare at it for years on end, doesn't move. And it's looking for this. It's looking for stars that go down in brightness and then go back up and then go down again. And what some clever scientists realize is that when you see this, what's actually happening is that planets are going in front of that sun and blocking a tiny, tiny portion of the light. So if you watch it and you see this happen over and over and over again, you're actually observing a planet that you hadn't seen before. It sounds simple, but in reality, it looks more like this. There's a ton of analysis and a ton of math that goes into it. And most of the team is actually mathematicians that try to crunch this and figure out what's actually going on, what's a planet versus what's just anomalies and noise and things like that. But they succeeded, and they literally found thousands of planets. But because the team was composed of mathematicians, the way they told the world that we have found planets is by publishing an Excel sheet. These are other planets. Stuff drives me crazy. So, we sat down with them. To their credit, they're like, how can we better tell this story? And we looked at this, and we knew it was sort of a visual, there was so much visual things we could do there. We started with this amazing visualization we found online. It wasn't very interactive. It just showed all the planets orbiting around a star. Someone had just built this because they were passionate about the topic. And we said, this is a great start. Where can we take this? What other ways can we visualize this? So let me show you that. Oops, let me restart it so it adjusts for the resolution. So we've got this first view here, and this is similar to what you saw, but what we've done is remap the colors. So the colors now represent actual temperatures that we're comfortable with. So the things that are red and orange are planets that you couldn't live on. Things that are purple and blue, too frozen. Those few green planets that you see, very difficult to see, but there's a few in there. Those are planets that we could actually live on if we went there. They're hard to see, so what we can do is filter it out to just those planets. And you can see there's about 200 of them. Some of them are really tiny, so let me make them all the same size so you can see where they are. And unfortunately, most of these are not confirmed. So to confirm, we have to have a different telescope check that same star and see that they see the same thing. So let's see how many of these we actually know to be true. They're still there. There's still 19 planets that are orbiting their star that are confirmed and are habitable, which I think is an amazing finding that you'd never see in an Excel sheet. So this is one way of telling the story, but I think there's others, so let's switch a couple of these things here. We put it in chart form for people that speak charts. This is great for the scientists. But what we also did, we noticed that we've got all these planets, but we've also got all these systems, all these solar systems. How can we show that? So we've got this view here. These are each individual star system that we found. There's almost too many of them, so I'm just going to filter down to the ones that have multiple planets around them. And just for a moment, I'm going to scroll through so you get a sense of all the multi-planet systems that Kepler has found. So this just goes on. There's a lot of them. I think that, to me, is the power of visual storytelling. You suddenly understand the implications of what this small little satellite has found. I want to show it to you in one more way. Let me switch these guys. So this is the portion of the sky that Kepler looks at, and each of these yellow boxes is one of its sensors, one of its cameras. So let me zoom in here. And as I zoom in, let me switch some of these off, we start to see that almost every single one of the stars it looks like is circled in red, which means that it has a planet around it. This blew my mind because our understanding before was that planets were rare, and now we've arrived at the opposite conclusion, which a star without planets is extremely rare. Planets are everywhere in the universe, which is an amazing story and one that was difficult to tell without doing things like this. So, let me quickly conclude here. Actually, there's a little bit more to the story. We created this about a year ago, and the scientists said this is great, but we want to wait until we publish a specific paper before we share it with the world. And if you know scientists, papers tend to get delayed and delayed and delayed. In the meantime, while they were writing that paper, the New York Times published this, which was interesting. It was interesting to be scooped by the New York Times. But I think the lesson for me was that if you don't tell your story, someone else will tell it for you. So we went to 3 different places: the moon, space, distant worlds. My hope was that by moving these UIs a little bit forward, instead of being bored when you see these interfaces, you look more like this, just in awe. And I tried to understand what lessons we could sort of distill from that. What things could you apply in your UIs to get this kind of reaction? The first one is just be visual. If you have a spacecraft that's literally in space, somewhere in your UI, I beg you, show a spacecraft in space. Make that visual. Be inventive. The command line interface was formed around these set of constraints that I hadn't seen anywhere else. I think constraints are great, and if you embrace them in the right way, you can create a UI that you wouldn't see anywhere else because you've so well embraced them. I think we have a lot of opportunities to do that in a lot of the things we design, and I hope that you guys sort of move towards that direction. And most importantly is tell a story. I think that's the reason we design, is to take some ideas and get them into someone else's mind. And a UI can do that, but a story can do that much better. And I know, looking back, the things that have inspired me are stories, so I hope we can make more of them. Thank you.
Okay, questions for Sam? In the back, there. Oh, there's a microphone coming towards you. Okay. Do we have it on, guys? Yep. Okay. Maybe you want to do some work on microphone interfaces as well.
Unsolved problem.
Yeah. Okay, maybe you can shout.
Shout.
Yeah, we're there.
All right, so it seems like they have a lot of information to distill if we could make any attempts to interface them. How do you deal with that, with an organization that's complex as NASA?
Yeah, I think one of the challenges is that each of these things I showed, there's a huge iceberg of information that you have to sort of understand before you can really design these things. And so the approach we took was to be as close to the user as possible. There was someone on our team who probably knows more about the power system on the space station than anyone else, even the people that designed it. And that was very much our approach. We'd read through the manual. We'd often do the job ourselves. For the space station work, I was actually one of the mission control people for a few of the missions, so I fully understood what was going on. And I think only by really embracing being the user could we get there so quickly.
One more question. You get to go into space?
I keep making that pitch. No one listens to me. It's one of these days.
More questions? Okay, I have one about the timelines. For example, the
Sure.
Kepler project. What's
Yeah.
the timeline for that from first briefing to?
Yeah. I think it depends on the mission. For the Kepler, it was something like on the order of 6 months. And really, a lot of that was just waiting periods as we tried to understand and talk to the users. But most of these things we tried to build very quickly and iterate on them. I think that's just a good design principle. And
So the building process, time to build, was just a small portion of this 6 months.
yeah, I think technology is the easy part. It's talking to the users, understanding them, selling them on these ideas, and then making sure that the thing you build is actually useful for what they're doing. And so for most of these, they were 6 months to a year, and really it was just having a small team that enabled that. It was just me and 2 or 3 other people on almost every one of these projects.
Okay. Thank you very much. Please give a hand for Sam Hashemi.